Hey everyone, and welcome back to Conceptual Math. I'm super excited you're joining me for today's explainer, because we're going to tackle something that pops up, well, literally everywhere, both in school and just going about your day. We're talking about converting fractions into decimals. So, let's just jump right in.
Let's be totally honest for a second. Do you ever find converting fractions to decimals just a little bit tedious? Yeah, you're definitely not alone. It's a super common hurdle. But here's the really good news. Once you click with the underlying logic of tenths, halves, and quarters, decimals become incredibly easy, like second nature easy. You won't even have to think about it.
All right, section 1, the concept. What exactly are decimals? Let's build this up from the ground floor.
Okay, picture this. Imagine you have a complete, solid object. Maybe it's a block of wood, or, hey, maybe a rectangular cake. Now, you slice that cake up into exactly 10 equal parts. Just one of those individual parts? That's called 1/10. In the fraction universe, we'd write that as 1 over 10. But over in the decimal universe, we just write it as 0.1. So let's watch this pattern unfold. If we take that exact same cake, still sliced into 10 equal parts, but this time we grab 2 of them. Now we got 2/10. As a fraction, obviously that's 2 over 10. But as a decimal, it beautifully translates straight to 0.2. Are you kind of seeing the pattern start to emerge here? The numerator, that top number in the fraction, it basically just slides right into that very first spot after the decimal point. Let's keep that momentum going. If we've got 5 over 10, it just equals 0.5. Got 7 over 10, that's 0.7. And let's say you take all 10 parts, 10 over 10. Well, you've got the whole cake back, one complete whole, which we simply write as 1.0. The logic here is just wonderfully elegant. Whenever your denominator, that bottom number, is 10, your numerator goes straight into that very first decimal place, every single time.
Moving on to section 2, the golden rule of denominators. Seriously, grasping this one rule is going to save you so much time.
Okay, this is basically a cheat code. It's all about counting the zeros. Just look at your denominator. If it's a 10, there's 1 0, right? Which means you have exactly one decimal place. If the denominator is 100, that's 2 zeros, so you get 2 decimal places. And if it's 1,000 with 3 zeros, you guessed it, exactly 3 decimal points. You literally just look at the bottom number, count the zeros, and set up your decimal points to match. It's that simple. Let's take this golden rule for a test drive with hundreds to show you just how foolproof it is. Say you have the fraction 25 over 100. Look directly at that denominator. The number 100 has 2 zeros. That explicitly tells us, without a doubt, we need exactly 2 digits right after the decimal point. So the 25 drops in seamlessly, and boom, we get 0.25. Pretty straightforward, right? All right, let's escalate things to thousands. Here, we're looking at a fraction of 125 over 1,000. Applying our rule, 1,000 has 3 zeros. So that demands 3 places after the decimal point. And since our numerator, 125, is already a 3-digit number, it perfectly fills those open slots. You effortlessly land at 0.125. No stress involved. Ready for section 3? Easy conversions practice. Let's do a rapid-fire round. See if you can guess the decimal right before I say it.
First up, 6 over 10. Think about the zeros for a second. What does it become? Yep, exactly. Because of that single zero in the 10, it instantly snaps into 0.6. 1 0 equals 1 decimal place. You got it.
Okay, now let's try a slightly trickier one. 4 over 100. Our rule screams at us that 100 has 2 zeros, so we absolutely must have 2 decimal places. But wait, we only have a single digit in our numerator, just the 4. So what do? We drop in a placeholder 0 right in the front, making it officially 0.04. Let's push this even further. What about 8 over 1,000? Enforcing our 3 decimal place rule, because, 3 zeros in 1,000, we have to pad that number 8 with 2 placeholder zeros in front of it. That leaves us with 0.008. If you caught that on your own, you've completely mastered this rule.
Next up, section 4, when the denominator is not 10. So, what exactly happens when our base number isn't a friendly 10, 100, or 1,000?
Let's break down a super common fraction, 3 over 4. We'll do this in 2 simple steps. Step 1, we essentially engineer the denominator to become 100.
Mathematically, we know that 4 times 25 equals 100, right? So whatever we do to the bottom, we absolutely have to do to the top to keep the whole thing balanced. 3 times 25 is 75. Boom! Now we have an equivalent fraction, 75 over 100. Step 2. Just apply our golden rule. 2 zeros mean 2 decimal places, easily giving us 0.75.
Let's reinforce this little trick with 1 over 2, a half. To make that denominator a friendly 10, we simply multiply the bottom by 5. We multiply the top by 5 as well, naturally, and we get 5 over 10. Apply the 0 rule, and that instantly transforms into 0.5. And the exact same logic works for a fraction like 3 over 5. Multiply both top and bottom by 2, you get 6 over 10, which quickly converts right into 0.6. Okay, Section 5, real-life examples, pizza and chocolate. Because, let's be real, we need to ground all these abstract numbers in the real world.
Imagine you order a massive, delicious 10-slice pizza. You've got some friends over, and together you absolutely devour 7 slices. As a fraction, you've eaten 7 over 10 of that pizza. Convert that to a decimal using our rule, and you get 0.7. And here's where it gets super useful for actual daily life. A decimal of 0.7 is exactly the same thing as 70%. You literally ate 70% of the pizza.
Now let's take that exact same logic but apply it to dessert. Think about a massive 100-piece chocolate bar. If you manage to eat 25 pieces of it, that's a fraction of 25 over 100. Our golden rule spins that right into the decimal 0.25, which means you just consumed 25% of the chocolate. Decimals are basically just percentages wearing a disguise. Once you see that, they become incredibly useful to understand.
Ultimately, decimals aren't just some abstract exercise for a math test. They are vital, everyday tools. Whether you're glancing at price tags while shopping for groceries, calculating change at a register, or trying to get precise measurements for a DIY home project, decimals are the standard language we all use to describe parts of a whole out there in the real world.
So let's quickly recap what we covered in today's explainer. We learned that converting fractions to decimals is really all about finding a base of 10. We unlocked the rule of 10, 100, and 1,000, a reminder to simply match the zeros to our decimal places. And finally, we saw exactly how this math steps outside the classroom and right into our daily lives. If you found this helpful and finally clearing up decimals for you, please be sure to like, share, and subscribe to Conceptual Maths.
But wait, before I let you go, I want to leave you with one final, slightly tricky thought to chew on. Imagine you somehow end up with an improper fraction. Let's say 8 over 5 of a pizza. What exactly would that look like as a decimal? How do you apply our rule to a fraction where the top number is actually bigger than the bottom number? Think about it, test out the math on your own, and keep exploring. Thanks so much for joining me for this explainer, and I'll catch you next time.
Thanks for watching. Bye, students. Don't forget to subscribe for more math fun videos. See you in the next lesson.